Okay, ladies and gentlemen, this is going to be a multiplying polynomials video. Okay, multiplying polynomials. When we multiply polynomials, we're going to use a method that is called the box. Yes, the box that rocks. Okay, so here we go. For these first few examples, the box is pretty optional. It's very optional. In fact, probably I wouldn't use the box, but if you like the box and want to use the box every time you know it's time to multiply, that's why I'm going to show you this. In case you want to use the box every time you get ready to multiply, so that way you don't have to memorize 15 different ways to do stuff. One way, the box, okay? So here we go. Your job is to understand how many terms we've got, okay? So how many terms are being multiplied by how many terms? This problem has one term being multiplied by two terms. So 1 by 2 is going to be the measurement of the box I'm going to draw. And when I say 1, I mean 1 tall and 2 wide. So I'm going to make a box that is 1 box tall and 2 boxes wide. Okay, my first polynomial, it's a monomial, goes on the outside because it is one term. So it goes on the 1 box tall side, okay? Now my 2 terms over here, and how do I know it's 2 terms? Because I always circle my pluses and minuses, and it breaks it up into sections. That is 2 terms. They go up here. 1 term per box. That -7 goes here. Don't put that negative in the middle. Give it to the 7 so that we remember that's a -7. Okay, so now we multiply. And you just use your fingers like this. Wherever your fingers meet, that's where the product will go, okay? So we're gonna multiply the big numbers, multiply the coefficients, and add the exponents. So -4 times 2 is -8. And a times a, we're just gonna add those exponents, 1 plus 1. Okay, you gotta remember your exponent rules on this, okay? When we multiply terms, we multiply the coefficients, but we have to add exponent. We use that addition rule we learned 2 units ago. Okay, and then for this box right here, we just need to multiply the -4 times the 7, which is positive 28. And then we have that a, and there's no powers to add it to, so just a. Okay, so in the boxes now, we have our answer. And it's really as simple as that. It is -8a squared plus 28a. Now, I said you could do this another way. Of course, you can always distribute. Look, -4a is knocking on the door, and we got to multiply it by the 2a. Do the same thing. -4 times 2, -8. A times a squared. Then -4a gets multiplied by this -7, and you get the same exact answer. But once again, if you want to think of multiplication and want one strategy to do that every time, the box. Okay, we'll do one more of these, and then we'll do larger boxes. All right, here we go. This is 1 term multiplied by how many terms? 1, 2, 3 terms. Okay, so we need a 1 by 3 sized box. 1 tall, 3 wide. Okay, we're going to put our 5c out here, our 10c squared, our -11c, and our positive 10. Go ahead and verify that you got each term and that each term has its own box. Next, we multiply. Multiply these two together. The 5 and the 10 get multiplied, and that is 50. The c and the c squared get multiplied. We add those powers. That's a 1. 1 plus 2 is 3. So it's going to be c to the 3rd power. Then we multiply these two. 5 times -11 is -55. We add the powers. When there's no power written, it's an understood 1. 1 plus 1 is 2. C to the 2nd power, or squared. All right, and then 5 times 10, 50. That's a positive 50, so I remember. And we just have that one c, and there are no more powers of c to add that to. Got it? That's it. That's our answer. It's staring us in the face. You can just write it out over here to the side. 50c to the 3rd power, or cubed, minus 55c squared, plus 50c. Okay, you can finish problem number 3 on your own. Once again, we could have distributed this if distributing works better for you. Now, let's do some larger boxes. Okay, how many terms do I have in this first polynomial? 1, 2. 2 terms. How many terms do I have in this second polynomial? 2 terms. So this is going to be a 2 by 2 box, 2 tall and 2 wide. 2 tall and 2 wide. Everywhere I put a dot, you're about to put a term. Okay? So let's deal with our first polynomial, x plus 7. Do you want to put it here or do you want to put it here? You can put it anywhere you want, but you may not break it up and you may not put it out of order. Okay? So I'm going to put it here. X goes first, then plus 7. And when I say first, I mean on top. Okay? So x and then positive 7. My next polynomial, x plus 4, x and plus 4. Do not put the plus 4 first and then the plus x. Everything has to be in order. All right, and now we multiply. Now you're going to use your biology Punnett square skills, okay? Because we're going to multiply this just like the Punnett square works. So use your fingers if you have to, but these get multiplied and we put that answer in this box. These get multiplied and we put this answer in this box. These get multiplied, answer goes in that box. These get multiplied, answer goes in that box. Ready to multiply. X times x. Once again, when we multiply, we add powers, okay? So 1 and 1 make 2. That needs to be x squared. If your first box isn't squared, you know you did something wrong. X times x does not equal x, okay? All right, now here, x times 4, positive 4x. And I can even put that positive 4x so that I remember. X times 7, positive 7x. And 7 times 4 is positive 28. Now when we're multiplying, this is going to be our answer. Here we are. X squared plus 4x plus 7x plus 28. What we're always going to have when we multiply are like terms. Like terms. Okay, so this is technically our answer, but we can condense it. We can make it shorter. This is too long. We can condense it. So you're going to take this 4x and this 7x and combine them because they will always be like terms. In fact, when you're using the box, your like terms will always live on this diagonal right here. Never this one. Never here. Here's where you should always have your like terms. So it's easy to check if you're doing it right, because if these don't match and they don't both have 1 power of x on them, you did something wrong. Okay, so set 4x's plus 7x's. How many x's do I have? 11 x's. So my final answer will be that. Okay, let's do one more. Here we are. Problem number 5. Let's try this. Once again, I've got 2 terms by 2 terms. I need a 2 by 2 box. 2 by 2. There we go. Now let's put our terms where they go. 2y goes first and then minus 7. Up here, 3y goes first and then minus 4. Let's get ready to multiply. 2 times 3 is 6. Y to what power? Well, 1 and 1 make 2. Okay, now over here, multiply these two, put it here. Multiply these two, put it here. 2 times negative 4 is negative 8, and we've only got 1 power of y in both of these terms, so that's all we have. Here, negative 7 times 3, negative 21, and we've only got 1 power of y that we're dealing with. Over here, negative 7 times negative 4, there are no y's, so when I put my product here, there should be no y's, okay? Negative 7 times negative 4 is a positive 28. And now, we can do our thing. Once again, make sure these are like terms, because if they're not, you did something wrong. So here's our answer. Can we just do that in our head? No? Okay, well, let me write it out. But if you can do it in your head, then go for it. Add those together, those are like terms, and we end up with that's my final answer. Okay? Now I've got one more fun example for you. All right? On this worksheet over here, there are 2 errors. So if you're using the same worksheet that we used in class, remember that there are 2 errors on this page. So let's fix those now. On number 10, there's a missing k. It's supposed to say 3k squared plus 12k minus 11, okay? And then on number 11 also, there's a missing middle term. I'm not sure how this made it through, but it did. All right, so I apologize in advance. We're gonna work number 10 together. Problem number 10, we'll work it together, okay? Now, what size box am I gonna make? That's always the first question you ask yourself. I've got 2 terms by how many? Ooh, this time 3. I need to make a 2 by 3 box. 2 tall, 3 wide. Let's go. Got it. Okay, now 2k plus 1. Why does this go here? Well, because it's 2 terms and I have 2 boxes, okay? Now over here, these 3 terms right up here. Always verify that you've written everything correctly because the leading cause of mistakes is writing the question wrong from the jump. All right, let's do this. 3 times 2 is 6. How many powers of k am I dealing with? 2 plus 1, what does that make? 3. Okay, how about here? 12 times 2 goes here. 12 times 2, 24, positive 24. How many powers of k am I working with? This one has 1, this one has 1. That is 2 powers of k. Next, 2 times negative 11, negative 22. And between the 2 of these guys, I've only got 1 power of k. Next row, 3k squared times 1. Well, 3 times 1 is 3, 2 powers of k in this problem, so there we go. In fact, look, I'm multiplying all of these by 1. What do you think is going to happen? Well, this times 1 is just going to be what it is. Timesing by 1 doesn't do anything, you guys, okay? 1 times negative 11, negative 11. All right, now, being that this is an extra large box, how many diagonals do you see? Here's a diagonal, and it happens to have like terms. Is that a coincidence? No, that's why the box rocks, because my diagonals always have like terms on them. Okay, here, k to the first and k to the first power. Hey, they match again too. I'm going to have 2 whole sets of like terms to add. I'm not going to write all this out because that's just too much writing. I do know my first box has my first term in it. I'm going to copy that as is. My last box has my last term in it. I'm going to skip a bunch of space right here in the middle. I'm going to write that down. Now, add these 2 together. 24 plus 3 is 27 with a k squared, because remember, when I'm adding like terms, my powers do not change. That's why they have to match in the first place, because they don't change when I'm adding. All right, then over here, negative 22 plus 12 is negative 10 with 1 power of k. So I've added this set of like terms and put it here. Does that make sense? That is your lesson, multiplication with polynomials.